Hi Joyce, hi Gerardo. So they just took their Forever Endeavor quiz. Thank you.
All the answers are the same. Put the same
all
words.
the answers are the same.
All the answers are -3.
All the answers are Jesus.
That's true.
Kind of. So anyway, coming back. I'm giving them 2 handouts today. I'm giving them a chapter review and like a summary, a flowchart of all the different tests that we have done, how to approach a problem where you're trying to figure out convergence, divergence. A quick summary of each of the tests, but in more detail than your Forever, just a little bit more detail than your Forever Endeavors. And then a silly way of remembering all of the tests. 1, 2, 3, 4, 5, 6, 7, 8. Why isn't there 9? Wait, what are we missing?
One of those
Is
probably
it direct and limit comparisons? Are they together?
Oh, yeah. Direct and limited together.
Where's the,
I thought there should be one more.
what's the limit?
At the very bottom.
Oh, comparison.
There's a silly acronym, right?
Yeah, that's the
Called parting C, like parting and then the letter C in the back of this packet. Where it says, well, it's basically just a way of remembering all the tests, not necessarily the order. The flow chart kind of tells you the order to approach your problem. Try this, if yes, then this, if no, then this, etc., etc. Which is kind of nice for some of you. For some of you, it's just going to confuse you, so I just thought I'd throw it out there. This is how some other classes, some other teachers actually teach it and have the kids go through it. The parting C is just, you can think of P for P series, A for alternating series, R for ratio test, / root test. There we go, there's the 10. Because telescoping wasn't in my list of 9. So R can be for ratio and root, T can be for telescoping, I for integral, N for nth term, G for geometric, and C for comparison test, direct, and limit. But that's just a silly way of remembering for you guys to have. So the flowchart and all of that is just literally resources if you want to try to kind of tune your brain for how to think through what to do, etc., etc. But otherwise, the chapter review is 46 problems. Let me see if I can actually input it in my Bob. And the reason I'm giving you all of this right now is because we have a test on Wednesday. Boop. Tomorrow is a work day. So I'm giving the test review today, and ones you got stuck on tonight, etc. You can check it out. I don't technically have an answer key. There is, or there are series calculators where you can type in a series and get the convergence, and there are no ... George, on this.
Yeah, I know.
Although the ... ended up easier than you would expect. 9-6 is supposed to be due today, so we'll go over questions if anybody has them, and you can also, I suppose you can ask tomorrow. And that's pretty much all we're doing today. So, let's start with 9-6 homework. How'd you guys do? Any questions that we have?
I think that's so long.
I didn't do it.
It was the root and ratio? Oh no.
It was above.
This is what showed up in my notes for the test review. It's kind of sad. Can I actually get rid of this? No. I guess we can talk about it.
I have 3.
Questions? Okay, what do you got?
Number 17.
Okay.
Number 59. And then number 64. Which I think 64 we've done before. N of n over n squared. Is that the extra credit one we have one time? I don't know if I do it now.
Yes. Was that the exact one? I think it was just ln of n over n.
Oh, it might have been then.
Okay, start with number 17, and then let's go ahead and just go from there. So, and we have some homework questions after this page, but I'll just import from here because those are the ones that you were asking. So number 17, what do we got?
N.
1 second. Oh no. Ooh, I can do graph paper. That's cool. Standard. Yeah. I'll just keep it plain. Okay, number 17. Sorry.
Is n times 6/5 to the n. Oh, and it's from 1 to infinity.
Oh, 6/5.
Yeah.
Ah.
Oh, this one, it was like weird to, it was like easy to use root test, but like I had no idea how to use the ratio.
Yeah, because it says that you have to use the ratio test for this. But I don't know how to do it. But it works with the root test. Oh, yeah, true. Because it's n to the 1 over n and then times 6/5. Oh. Can we just use root test?
Yeah, you just have a bigger picture and use root test.
So
ratio test shouldn't have been too bad though, was it?
I don't know, I like couldn't figure out how to do it.
Six fifths. I just do not like writing that today, I suppose.
That's a stupid number.
Whoa.
I think why I was so confused is because I was trying to flip the second one and then I didn't.
Oh, and there was no. Yeah. I bet that's what was messing you up.
Yeah, I think so. That
There you go. So you could do 6 fifths, which is greater than 1. And what do we know as a result? Uh-oh.
the divergence.
And some of you might also look at this and say, like, can't the nth term kind of tell you that too? Because as you keep on growing, it's expanding. The limit is not 0. You could probably do nth term also, but then root test works as well. Remember, just keep a big picture in mind in the sense of, for the test, one more time, I'm giving you a huge, not a huge, but I'm giving you maybe like 10 to 15. And I just need you guys to go through the list and figure out a way to show me each of the tests one time, which means you don't have to do all the problems, you just have to pick the ones where you can use the tests each once. So, if you needed a ratio, this could do it. If you needed a root, this could do it. If you needed an nth term, this could do it. Anyway, all the above, series diverges. Yeah.
If I have like cosine n over n squared, and since it's alternating, would my like
Ooh, but cosine doesn't perfectly alternate because you would have cosine of 1 and cosine of 2. If it was cosine pi n, you can make it alternating. But just cosine of n, I would use limit comparison.
very like n squared,
Yeah,
1 over n squared.
yeah, so that would be. Is it cosine n over n squared? Is that what it is?
Cosine n over n squared. Because the n squared will cancel out and get cosine n, and that's squeeze theorem in between negative 1 and 1, and then that would mean it
For the comparison test, does it have to be strictly positive?
has to be greater than comparison.
Does it just have to be greater than?
Um,
I should know this.
so limit comparison with positive terms.
Can't do integral tests.
I do direct comparison?
No, direct and limit both in the same conditions, don't they?
Yeah. Make it better 1 over cosine?
Well, it's a squeeze there, but that's not exactly what they're asking.
Yeah, make it better 1 over cosine. Then it cancels. 1 over n squared equals 0 over cancel.
But
Cosine diverges, right?
whenever cosine could be secant, and you could use ln of secant plus tangent.
But I would have to compare to cosine, but it would flip becoming 1 over cosine, but then cosine would cancel over n squared 0.
Do you guys see the series you're thinking about? He's thinking about cosine of n over n squared. I think it's one of the first ones on the
It's
review.
really
Yeah, it's the first one.
So you could only change it to like the alternating series if it's pi times n.
Because that's between 1 and negative 1.
Always, yeah. That was one of the problems on the
Oh yeah, that one did have pi.
Oh, wait a minute. Base of n, base of n greater than 0, and absolute value. Then we use absolute value, base of n and base of n greater than 0.
yeah, absolutely.
I mean, it is going to alternate in terms of, that's cosine of 1, cosine of 2. Cosine of 1 will be the first quadrant, cosine of 2 will be the second quadrant, cosine of 3 will be the second quadrant.
Can I integrate?
I was thinking of lucky 7 you could integrate.
Cosine of 1 over n squared. I'll try that.
Because you could integrate cosine or over 1 over n squared.
The thing is, I plugged it into this thing and it says absolutely, or converges absolutely. So that's why I thought it was.
distinct. That's what I was thinking. Is it gives you absolute value of it. That's why I was like, oh, it's not bad.
I'll try integrating both.
So it does alternate signs, but not every other. Where's okay? Hold on. Where's alternate series test? Is that the form? Negative 1 to the n. I would Google, can you use alternate series test with cosine n? Okay, I would Google for you. So if you can just treat it like an absolute value, and then you can compare it to 1 over n squared, which is always greater than or equal to. So then the bigger converges, and it's pushing for direct comparison actually. This cosine will go between 0 and 1. I swear we've seen that one in homework. What was number 59?
10n plus 3 over n times 2 to the n. And you can use anything for this.
What do you guys think? I would think ratio just because I don't want this guy raised to the 1 over n. You know what I mean?
Mm-hmm.
Like, ew. 1 over n is tricky because it's e or it's nobody that we know. So I think I would just do ratio test. And then you would have, can I do some mental math? So 10n plus 1 would be 10n plus 13, right? So you have an extra 10 over n plus 1 times 2 to the n plus 1. Then you have your n times 2 to the n all over 10n plus 3. Does that make sense? Then you can simplify that. I'm going to have a 2 in the denominator. Because that will reduce with that. Then I can have a 10n squared plus 13n. And then I have my 2 out in front. I could FOIL these two. So I would have 10n squared plus 13n plus 3. And then my limit would equal 10 over 20, so 1/2, less than 1 series converges by ratio. Does that make sense?
Yeah.
Cool. And then the last one, 64?
Yeah, it was ln of n over n squared.
That's more interesting. From 1?
Yeah, 1 to.
ln of n plus 1 we don't like because that's just wordy. Although, the root test, we're raising this whole thing to the root, right? To the 1 over n?
Yeah.
Oh, the whole thing. Ugh, I don't want to raise the whole thing. I was thinking ln of n to the 1 over n, but that's not going to help us. Oh, it did? Okay, that makes a difference. I was like, root
Oh, does it
ratio
really?
doesn't make sense.
Limit comparison? Yeah.
Yeah, that's what I was thinking was limit comparison.
But 1 over n squared is smaller, not bigger. Oh,
If you
limit
do-
comparison could work though. Yeah, I was thinking direct comparison.
Oh, and n over n squared would be bigger, but diverges, that doesn't help. Limit comparison, it'd be infinity with a, that's not good. 1 over n would give you ln of n over n, which is 0, that doesn't help. N to the 5/4, would that be this one? by p series, p is greater than 1. So we can have the limit as n goes to infinity of ln of n over n squared with n to the 5/4. And that'd be n to the 1/4 on the bottom, right? Which would be infinity over infinity. I was just thinking L'Hopital's for sake of simplicity, which would then give you limit as n goes to infinity just to prove it, although maybe some of you can already guess what the answer is going to be. We can bring down the 1/4, we'd have n to the negative 3/4 bottom wins. So therefore, since the limit is equal to 0, and since we were comparing to a converging series, then we can say that the series converges. That works, right?
Yeah.
Yeah, this was the funny one that we had talked about earlier. At least one similar to it, where n to the 1 is not going to work, but n squared doesn't work, and n to the 1/2, you have to kind of like just narrow it down. Or 3/2, I think, didn't work. Okay. Check. So we got 17, 59, and then 64. So those are all checked off. George did bring up for our chapter review, which is this one, because my silly thing did not import the PDF and it won't let it save it as a PDF. What are we doing? N equals, is it 1 to infinity, George?
Yes.
Did you figure out if we're allowed to use all things here?
I did not. I went back to this. I think
It does technically alternate somewhat.
Can I call it AST?
For all training series tests, can we just say AST?
That's okay. Or you just do alt for alt series.
Can we do this in our homework or on some piece of paper?
If you can fit it, but it's pretty. What's the actual thingy? Because mine totally distorted it up here. Not really.
I was already doing
Probably separate is better. But you don't have to write a lot. Long story short, I just need to know what test you finally decide on doing. You don't need to show me like the narrowing down or any of that, and then what conclusion you make. You can make. Just to save on time, since we do have an entire workday tomorrow, let's pause on him. And let's quickly, since you guys are working on it over the weekend, what are some places on Chapter 9 AP, if any, that, hey, I wanted the number n squared. Oops, well, that helps. Look at number, whatever we just looked at. What are some places you had stuck, if any? Don't worry about in super, oh wait, sequence, never mind.
I know, I was doing that too, and it's okay. On 2A, I did a whole big thing on the integral test on why it diverges, and then I looked and I was like, why does it just say the limit? I don't understand. Then I was like, no, it's 0, you don't know anything. You do.
Struggle, sequence, not series.
Yeah.
But the whole find the nth term formula, I've never seen the AP test you on that. Because it wouldn't be a long answer. Like they're definitely gonna make FRQs about something different. And then multiple choice, if they gave it to you, you could just plug and chug and see which one matched. So don't worry about finding the rule per se, but just knowing what to do with the rule, just in case you guys were stressed about that for the test. What else on chapter 9?
This was proved by this teacher.
Jason was saying you can.
It says it converges. Well, it says cosine n, cosine n over n to the 3/4 converges. But I don't know. He's talking about bounding cosine n.
It's like a squeeze there between -1 and 9.
He says.
21
21.
C and
Yes.
24.
Ooh, yeah. 21C is a good one to look at. Do you want me to pick that? That wording, error less than,
Then can we also do 28?
whenever we're looking at error less than, what are we talking about?
Alternating series approximation.
Alternating series approximation, which says that the error found from the actual sum minus the n partial sum is less than a sub n plus 1, right? So that's what we're trying to think about. We have the alternating series up above. If it wasn't alternating, we'd be in some trouble because we wouldn't know what to do with it. It's trying to find the number of terms necessary to approximate the sum of the series. So we're trying to say that this error has to be less than 0.001. But we don't know who the actual sum is, and so since we don't know what the actual sum is, we can't compare to this guy. But what we can do is we can compare to the n plus first term. So we have to set him, is it less than or equal to technically?
Yeah.
We have to set him less than 0.001. So this is what we're going to take because we can find the n plus first term from up above. Remember, it's absolute value of the n plus first term, so let's ignore the alternating part of the series up above. So we just are going to take the 1 over 2 to the n plus 1, right? The n plus first term is less than 0.001. Basically, you solve it. So, how do we solve that puppy?
Multiply both sides. Both. Set it up. Yeah.
Yeah, we can make it nice and pretty, right?
Yeah.
So we can do our 1 over 2 to the n plus 1. Less than, that'd be 1/10,000,000. And that leads us to 2 to the n plus 1, which is not the same thing as 2 to the n times 2, right? Is greater than 1,000. That will make life a bit easier.
Yeah.
Then we can divide both sides by 2. So we'd have 2 to the n is greater than 500. Ooh, how do we get rid of an n? Wrong one. And then this little n can pop down, right? So we have ln of 2 that's just being multiplied by him. So we can go ahead and take ln of 500 divided by ln of 2. This would definitely be a calculator problem. There are very few that would be. Oh, perfect. P.S. These are good ones to look at.
I did the first one, and then I got halfway through the second one. I still want to count.
What's ln of 500 divided by ln of 2?
Oh, and a 500 might? No, that's not. I'm just gonna bounce my answer. Stick to the math. It's not multiple.
Well, but remember, we have to make it a whole number, and we have to make it one higher.
I got 8.965.
Oh. 8.96 something? So we don't need to go full one higher. All we gotta do is round up, right? So n equals 9 would be more than sufficient. Does that make sense, guys? Remember, next one was 28?
24.
24.
Choice. Where was this earlier? Come on.
Come on. Well, first of all, we have to figure out who s sub 2 is, right? So s sub 2 is equal to 4 over 1 plus 4 over 2 squared is 4 over 4, which is 1.
Yes.
This was not an easy problem at all. I'll look at that later. So we end up with 5, yeah?
Yeah.
Okay. But then we know that s minus 5 has to be less than or equal to a sub n plus 1, which would be 4 over what? 9, right? This would be the next term. Doesn't that mean absolute value?
Yeah.
Can't we set this less than or equal to 4/9 on this side? What would be on the other side?
-1.
We could change 5 to be 45th. 45/9. And then we can add 45/9 to the left, and we end up with 49/9. And we can add 45/9 to the other side, and we'd end up with 41/9. So my assumption is that one. Am I off?
No, it's right.
Haha.
Probably seen
Dun,
that.
dun,
What
dun,
did you
dun.
get?
49.
Oh, because when you're expanding the term, you get 4/1. 4/2 times 2 is 4/4. And 4/3 squared is 4/9. 4/4 squared would be 4/16. So since we just took those two for the n, or for the second partial sum, we took the third term. Remember the n plus first. Does that make sense?
Miss D?
Yeah.
If it asks which of the following series converges and something is conditionally convergent,
What I'll say in the test, and I think it's similar to theirs, if it's an alternating series, go further to say whether it's conditional or absolute. But for the rest, you just have to say convergent or divergent.
I mean, like for
Oh,
Cat
sorry.
5, it's multiple choice, and then I think number 2.
Conditionally convergent suffices because it says what you see there converges.
And the other two diverge. So, oh no, the answer could be none.
What?
I said the answer could be none, but I was gonna say one of them has to converge.
Yeah, well, it does. Number 2 does, right?
Yeah.
Yeah,
Conditionally
converges,
convergent.
converges.
And then the other 2 diverge.
Yeah.
By
So conditional counts as converged. We just have to, conditional, the alternating one does, absolute means it doesn't matter, so yeah. Conditional counts.
Yeah, Cosimo. What does it have
So
to
we
be
don't
to
work
make
on this
conditionally
tonight, or do you work on this tonight?
If you haven't finished chapter 9 AP, I would do that first, and if you have finished chapter 9 AP, then work on the review. If you want to skip over some you don't know, then bring those as questions.
What does it actually mean to be conditionally convergent? Like, does that mean something?
Means that the alternating series you're looking at does converge, but it's only because of the alternating sign.
Versus.
Versus it doesn't matter whether or not the alternating will converge. Does that make sense? So it's like a broader question that you're answering with absolute convergence.
I just need to have.
Ooh.
Yes, please.
Yeah, you're gonna pause it. Thanks.